This is a conversation that I typically have with my students after the first exam. What is the best way to study, and how do I get an A? So I've put 8 different study methods down here, and I'm going to place them on this tier list. So let's see how they do. So S tier is the highest, all the way down to D, which is, I would not recommend this. It's probably not going to be that helpful for you. So to start out, let's start with Chegg. So Chegg, I'm going to place Chegg in D tier because of how it's used. So Chegg is just kind of representative of websites you can go to find solutions to homework problems. And usually the way that it's used by students is they have homework due the next day or in a couple hours. So they search the homework problem and look up the solutions, write down the solutions real quick and turn in the homework. Now, this gets you the points for the homework, but I know in my classes, for example, homework is worth 5% of your grade, which really isn't helping you all that much in the end relative to the weight of the exams, the weight of design projects, etc. Now, where solutions will help you is after you've done the homework honestly, and you want to go and check your answers. So let's go ahead and go to the second study method here, which is doing your homework. So I'm going to place homework in, ooh, this is rough. It's either going to go in an A tier or B tier. I'm going to put it in B tier for now. We might reorder this later. So the whole point of homework is just reinforcement of what you learned in class. So depending on the professor, you could be given anywhere from, let's say, 5 to 50 homework problems. And usually they're in the form of problems from the textbook, and it's just repetitive problem solving, utilizing the concepts, hopefully, that you learned in lecture. Now, this is good for reinforcement, but a lot of the times what happens is you get used to solving the specific types of problems that you see in the homework, and then when you see anything that's outside of that, you get thrown for a loop. You get thrown off guard and you get stuck. So that's why I'm going to place it in the B tier for now. It's necessary for the learning process, it's necessary for studying, but not the most effective method, I would say. So going back down here, let's look at practice tests. So practice tests, I think I'm going to put these below even Chegg. Now, I know students love a practice exam, and I know some professors love giving them out so that the students feel prepared for the upcoming exam. The problem that I have with them is, again, it's giving you a specific set of questions to solve and setting your expectations for the exam that the exam questions are going to be similar to those practice exam questions. And then anything that's outside of those practice exam questions is going to be a shock on the exam and is going to cause anxiety and stress. So honestly, when I'm reviewing for an exam, I just tell students, these are the topics that we covered over the past few weeks. I expect you to know them. The problems are going to be similar enough to homework questions, problems that we did in class, and utilizing concepts that we learned in class. Concepts for me, and I think for a lot of professors, are very important. And we can't put all of the concepts or all of the types of problems that we would want you to know how to do on a practice exam. So that being said, I think practice exams give you a false sense of security and, in my opinion, are a waste of time. Now, what would be a better use of time? So summarizing lecture notes, I'm going to come up here and place this in S tier. I think this is the most underutilized study method. So every class, probably, you're showing up in person, if it's an in-person synchronous class, and you're writing down notes either on paper or on your tablet, and those go in a notebook. You come back the following class, do the same thing. And I think this idea that has been passed around a lot by professors also is that somehow you are learning through the process of copying down the notes from class. And maybe in the short term, you are. It's helping you retain that information for the next couple of hours. But by the next day, definitely by the next week, you've probably forgotten quite a bit of that information. So the act of just writing down the notes the first time really isn't all that helpful in the learning process and helpful in you getting an A on that next exam. What is helpful is taking those notes and summarizing them down into a much shorter form. So the most effective way to do this would be right after lecture. Go and take, let's say you have 4 pages of notes, summarize those down into a single page, and then keep that. Do the same thing for your next lecture. After your class, go and summarize your 4 pages of notes down to another page. And then as we get closer to the exam time, when you're ready to, really study for this upcoming exam, take all of those notes and summarize everything down into a single sheet, ideally front side only. So a single piece of paper. And if you can get that down to half a sheet of paper, that's even more ideal. And I think that this should really be your first step for studying for anything. And it doesn't matter if your class is more conceptual based or if it's more problem solving or whatever. The lecture is really where professors are communicating the important concepts, the important first principles, the methods, the concepts that really allow you to solve any type of problem that falls within that field that you're studying. So, for example, if I'm teaching a statics class, which is a civil engineering analysis of structures that don't move or are moving at constant velocity, one of the most important concepts that we cover are Newton's laws, which is something that you cover back in physics. But Newton's second law, Newton's third law, so F equals ma, and action-reaction forces are fundamental to solving every problem in statics. Understanding triangles and basic trigonometry is fundamental to all problems in statics. And so reinforcement of these concepts and utilization of these concepts in problem solving typically happens in lecture. And you need to reinforce that to yourself. You need to actively learn, not just react. It's a little bit of play of Newton's third law there. But you need to be an active participant in the learning process, which sounds so cliche, but it's very true. You can't just sit there and watch somebody else and expect to become as good at the topic as them. So definitely S tier for summarizing lecture notes. So we got 4 more down here. I put raw intelligence and memory as one. So I'm going to place this in C tier. So you'll see students in class who are relatively smart in engineering. Maybe they're not even taking notes. They just get it quickly. And they don't study, or they say that they don't study. They show up to the exam. Sometimes they even finish the exam quickly, walk out, and they just seem like geniuses. And I placed this in C tier because without hard work, this is the grade that a lot of those students get. And I see this every single semester. Intelligence helps in engineering, but it's not everything. Some of the smartest people that I know are engineers, also some aren't. But even those smart engineers who are successful are also some of the hardest working people that I know. So intelligence and an ability to memorize things easily will help you, but it's not going to get you to that A grade. Engineering courses are too difficult for that, and the requirements and the applications necessary of this information just require hard work and grit that intelligence alone isn't going to do for you. So C tier, and some people might be okay with that and be like, I hear this all the time, right? Like C's get degrees. And I say, sure, they do, but they don't get jobs. So 3 more left here. Let's go with reading the textbook. I'm going to put reading the textbook in C tier. Now, some people like the theoretical reinforcement that they get from reading a textbook. I myself usually didn't get much of anything from a textbook. And I think the whole point of you showing up to class in the first place is for the professor to have synthesized what's in the textbook and present it to you in a more digestible manner. So reading the textbook by yourself now this is a little bit more specifically for engineering, I think personally is a waste of your time. A lot of the theoretical frameworks that are presented in those beginning parts of the chapter in engineering textbooks that pull a lot from physics and math are not necessary in daily practice as an engineer if we're just being real. At some point, you have to divert your focus to, okay, here's a problem. What is the algorithm or the method I need to follow to solve that problem? How can I utilize the bank of information that's either in my head or written down somewhere concisely to go and design something, make money, again, to solve a real practical problem. Engineering is all about practicality and solving problems. Projects and associations. So let's go with projects. I'm going to put projects up here in, we got to put something in A tier. So let's go ahead and put this in A tier. If you can work on a physical project that reinforces the concepts that you learned in class, that is only going to help you. With one caveat. Working on projects can get very interesting and very fun. And with that, it can become a time sink that takes away from your actual studying for exams or showing up to class or doing your homework. And if that becomes the case, then your grades are actually going to suffer instead of get better. So finding a balance, time management is really important when you're incorporating projects as a study method. But again, if you can work on some project that reinforces what you learned in statics or circuits or MATLAB, that's going to really help you in the learning process. And it's also going to add to your resume, which will be a future video. So how to craft a resume, how to get an internship, how to get a job in engineering. And then the last method that I have here is something that I think is not talked about very much at all, which is association or creating a narrative. And I'm going to put this up here right next to projects. So what do I mean by this? You learn a concept in class. So let's say trusses, right? So going back to statics. So in class, you learn that trusses are essentially a repetition of triangles or members that are connected at joints with reaction supports at the ends, and these are repeated structures that bear load. Cool. So we get into all this technical jargon, and then you solve problems. You maybe solve for the reactions at the supports, and then you apply method of joints or method of sections to solve for the forces and the members in the stress. And it becomes this very kind of like mathematical, repetitive process, and you can get bored by that really quickly. And you can forget why you're even doing this. What's the point, right? And I think you should always ask yourself that question in class. What's the point of doing all of this? Why, when we solve for forces and members in a truss, do we have to say whether something's in tension or compression? If you can associate the problem that you're solving to something that's real life, that's going to help lock it in your memory. So if you can connect the truss to an actual bridge, or this is one of the reasons why we have lab in class, right? So if you have a metal specimen and you do a compression test on it or a tension test, right? So like something actually physical where it breaks, and that act of something failing like really locks in your brain. You can see, oh, well, when I pulled this metal in tension, I got a lower stress value or a lower strength than when I put it in compression. So the tensile strength is lower than the compressive strength of a metal. And you see it with your eyes, you see it in practice. So then you're like, I understand why I need to know whether a member is in tension or compression, because stuff that's in tension fails earlier than compression. One way that I try and associate topics in a class to the real world is through current events in my properties of materials class. So material science is one of the newest and most evolving fields of engineering, and a lot of our engineering technology is dependent on material advances, or any of the advances that are happening are dependent on materials. So going and looking up just what is the new state of the art in material science, or Googling like new advancement in materials, or just taking a concept from your materials class or your statics class or your circuits class or whatever, and just Googling it and seeing like what the latest technologies and research are, and reading about them in the form of a news article, or even watching a YouTube video or even a short. This helps lock this concept into your brain. And we talk about this in academia as different teaching or learning modalities. So if you hear something, if you see something, if you can write something down, all of the different ways that you can synthesize information, they all link together, provide this association, and it helps you retain it in your brain. So if I were to combine all of these and recommend the best study approach to get an A on an exam, first up, summarize your lecture notes. Get everything down to a single page. Next up, go through all the homework and do the homework problems honestly. And you're going to make mistakes and you're going to get problems wrong, and that's okay. We learn through failure in engineering. After you've done that, go back through the homework problems and solve the problems correctly, utilizing the solutions that were provided to you from the professor or from online. After that, and I forgot to put it on here, but this is going to go into S tier also. You're going to get into a study session environment. So this is going to be up in S tier also. So you've completed your summary of the lecture notes, you've done the homework, you've checked the solutions to the homework, and all of this was done individually. And now you get with at least one other student, and my recommendation for this is a student that is at a relatively similar level to you. Relatively similar intelligence or ability to like get the material, somebody who you work well with, there's not any conflicts. And if this all works with 4 of you, then great. When I was in school, this ended up being just my friend Josh and I at one point, who studied together for the last couple of years of college, and it worked really well. Now, in this study session, you're going to follow a very strict format. And that format is going to be somebody writes a problem up on a whiteboard, and then one of you goes up, solves a problem, but as you're solving it, you're teaching it to the other person. So you're essentially acting as the professor during this process. And the student that you're teaching it to can then ask you questions, and you either answer those questions or you get the answers to the questions. And then once you've completed solving that problem and teaching it to the student, you guys flip, write another problem on the whiteboard, and that other student now teaches it to you. And you just keep going through that process, because the best way to learn material is through teaching it. And after having this career for 11 years, I can tell you that that's absolutely true. Teaching concepts really does reinforce it significantly for me as well, so I know that it works. Once you're through that study session, that's kind of the end of the study process. You should be pretty good to go. All right, hope that helps.